and one from quadratic equation. Okay, so let us take the second question first, right? Where it's given that if tan theta is the value of tan theta is given to you as a by b, right? Then we need to find the value of what? We need to find the value of a sine theta minus b cos theta by a sine theta plus b cos theta. Mind it, students, this can also come into the objective. Okay, because it can be solved within a fraction of second, but if you are not concentrating, it can take time. Okay, so I will explain the steps how to solve it. Okay, since in this question, just read the question very carefully. The value of tan theta is given to you, right? What tan theta? So what if the tan theta is given to you, but into the question only sine and cos is given? Okay, so which trigonometric ratio we need to use? Tan theta, because the value of tan theta is only known to us, right? So from one of the method, what we can do, just divide the numerator and denominator by what? Cos theta. When you divide the numerator and denominator by cos theta, what will happen? You can see the numerator will look like a sine theta minus b cos theta divided by cos theta, and this is a big fraction, divided by a sine theta plus b cos theta divided by cos theta. And when you are just, you can see this is inserted, this cos theta is inserted, right? So that's why you can see this can be cancelled out. So effectively our given ratio will be the same, that is a sine theta minus b cos theta by a sine theta plus b cos theta. So this will remain same irrespective of insertion of cos theta into the numerator and denominator. And into the numerator it is basically dividing the numerator, and this cos theta is also dividing the denominator. Okay, so there are two fractions which are formed. This is the upper fraction and this is the lower fraction, right? Now what we can do, just expand it. On expanding, what we can see, a sine theta by cos theta, which can be written as a times tan theta, isn't it? Right? And b cos theta by cos theta, you can, so rather than escaping the step, I can just write simply a sine theta by cos theta minus b cos theta by cos theta, right? This will be the numerator, and into the denominator we have a sine theta, because this cos theta is dividing individually this one and this one, right? So that's why a sine theta by cos theta plus b cos theta by cos theta. So here you can see cos and cos is cancelled out, cos and cos is cancelled out. So both the cos is cancelled out into the numerator and denominator, and we are left with this one, a sine theta by cos theta. And sine theta by cos theta is what? This is the tan theta whose value is given to you, that is a by b, this one, right? Now put up the value, a times tan theta minus b divided by a times tan theta plus b, right? Now use this value of a by b, then we can write a into a by b minus b divided by, we have just put up the value of tan theta over here, right? And into the denominator a into this tan theta, that is a by b plus b, right? Now on taking the numerator, you can see a square by b minus b, and in the denominator a square by b plus b, right? Now what we can do, we take the LCM. On taking the LCM, b will be the LCM, because here it's only 1, nothing is there, so 1 is the into the denominator of the second term. On taking LCM, b will be the denominator, b will be the LCM, and into the upper, into the numerator, a square minus b square, because 1 in b times becomes b, so b into b will be b square. This divided by, similarly taking LCM into there as b. So here this is the numerator and this is the denominator. Okay, I think you are not getting confused, right? So here a square plus b square by b. So here you can see b and b will be cancelled out, right? And we are left with a square minus b square by a square plus b square, right? So this is the answer. That is, what is our answer? This one, a square minus b square divided by a square plus b square. You can see this is numerator and this is the denominator. And in this way we have calculated the value of this one, a sin theta minus b cos theta by a sin theta plus b cos theta, and its value is calculated as a square minus b square by a square plus b square, right? So this value is calculated as a square minus b square by a square plus b square. This is our answer. I hope you understand. Coming to the second question of today. Second question is from trigonometry. The second question, the first question was from trigonometry, which we solved, was on number 2. But let us solve the second question. The second question is given that we need to find the value of p, where p plus 1 times x square. A quadratic equation is given to you, that is p plus 1 times x square minus 6 times p plus 1 into x plus 3 times p plus 9 equal to 0. This equation is given to you, right? Now what we need to do, we need to find the value of p. Find the value of p so that the given quadratic equation have equal roots. So we need to find p equal to what? For equal roots. You know, a quadratic equation, when it is solved, it is having some solution, and those solutions are called the roots of that quadratic equation. So we need to find the value of p for which the above quadratic equation have equal roots, right? So here you can see p plus 1 times x square minus 6 times p plus 1x plus 3 times p plus 9 is the quadratic equation given to you. Let us do one thing. You know the standard form of quadratic equation, it's ax square plus bx plus c equal to 0. You remember, right? Then just do the comparison. On comparison with the standard format, what we find, the coefficient of x square is a, right? And here in our quadratic equation, the coefficient of x square is p plus 1, right? So we can write a as equal to p plus 1, isn't it? And when we compare with the coefficient of x, it's b in the standard format, and in our equation it's minus 6 times p plus 1. So we can write the value of b as minus 6 times p plus 1. And what is the value of c? The constant term. In the standard format of quadratic equation, c is the constant term, and in our question the constant term is 3 times p plus 9, this one. So we can write c as 3 times p plus 9. Any doubt, students? Right? So here what we can do, just the value of a is found, b is found, and c is also found. Now what we can do, we can simply use the relation that for equal roots for equal roots d should be equal to 0. And what is d? D is the discriminant, right? D is the discriminant, should be equal to 0. And what is the value of d? D is b square minus 4ac, right? So what is b? We know this is the value of b, this is the value of a, and this is the value of c. So just put up over here to calculate the value of b. Since b is a into c is equal to 0, we can write this d as minus 6 times p plus 1 whole square. This is b square minus 4 into a is p plus 1 into c. What is c? C is 3 times p plus 9, right? Now solve it. Here you can see minus 6 and 7 is whole square, that is 36, right? And we are left with p plus 1 whole square, which can be expanded on the form of x plus y whole square, that is x square plus y square plus 2xy, right? Minus 4 into 3, this constant term will be multiplied, this will be 12 times p plus 1 and p plus 9 equal to 0. Here students, you can see p plus 1 and 12 is common in both the terms, p plus 1 and 12. So from 36, when 12 is taken out, 3 is left. So let us do one thing, take common 12 times p plus 1, and we are left with what? Here from 12, 3 will be left, 3 times p plus 1 is left, minus p plus 9, isn't it, equal to 0. Now this 12 gone to denominator and nothing is left, and we are left with p plus 1 so this 12 can be ignored, right? And this is not giving any value of p, and this is multiplied with all these 3 terms 1, 2 and 3, so this can be taken away. So p, we are left with p plus 1 into 3p plus 3. I'm just expanding the bracket over here, 3p plus 3 minus p minus 9, right? So this will give you p plus 1 multiplied by 3p minus p will be 2p, and 3 minus 9 will be minus 6, right? So this is equated to 0, don't forget it. So when we equate p plus 1 to equal to 0 and 2p minus 6 equal to 0, we get two values of p, 2p minus 6 equal to 0. One is what? One is p equal to minus 1, and another is p equal to 6 by 2. So this will give you the value of p as 3, and p equal to minus 1 already calculated. So we have calculated the values of p for which the given quadratic equation have equal roots. And what was that quadratic equation? That quadratic equation was this one, p plus 1 x square for, this is value of p for equal roots of, p plus 1 times x square. I'm just writing the quadratic equation over here again, minus 6 times p plus 1x plus 3 times p plus 9 equal to 0. So students, this was the quadratic equation which was given to you, and for equal roots we have to find the value of p, which we have calculated as minus 1 and 3. So many times question is given that just consider p not equal to minus 1. So in this way we could ignore this value of -1 and the only answer will be p equal to 3, right? So the question can be twisted and it can be put in front of you in form of some with some deviations. So don't get confused to solve our questions. Okay, thank you, like it and subscribe. Thank you, take care, bye bye. And also you can go through the playlist which I have updated into my channel. There are multiple quadratic equation questions, around 80 to 100 questions are there, which are selected questions. You can refer through those questions to build up your concept. Okay, they can be helpful for you. Depending upon the available time, you can go through. Thank you so much for watching, students. Take care, bye bye.